All right, so this is 121 here, computer forensics. And if we go down to the schedule, there's the recordings of the previous classes, and we're down to Module 3, which is about hardware. And your first couple of projects are due today, although if you can't do projects on time, turn them in late. There will be, at most, a small penalty of points. It's not worth doing at all if you're late, because you're going to need these. You're going to need to get your Windows machine for analysis running, and I saw a lot of students have done it. These projects are just getting a Windows machine of some kind running and getting Autopsy running on it. And then you can start doing ones where you analyze data with Autopsy, which is really very powerful. I had a student tweet me a few days ago saying, are we going to cover memory analysis? And I thought about it, and I said, well, we should. No, I had a really old memory analysis project that was pretty difficult, and I wrote a new one using Autopsy. As I thought, Autopsy totally includes the memory analysis tools I used to use and makes it easier to use. So anyway, I got the projects for about a month in advance ready here. And the data analysis ones are due on the 17th. Yeah, that's right. This is what that's data analysis ones. No, the data analysis ones are not due until October, because the next couple of weeks, the only thing due is these Autopsy videos, which teach you the fundamentals of Autopsy. And there's a quiz in Canvas to take about them. And so I recommend doing the first 4 of them, and then you can do the rest if you want to for extra credit, but I didn't find them all that exciting. But it seemed like the first 4 were pretty much worth doing. All right. So let's talk about the... I ought to have this somewhere. Well, I'll open it again. Must have closed it by accident. Let's talk about today's chapter, which is, in fact, I think, pretty short. And then I'll probably demonstrate a project or two. Let's go to Canvas. Oh, some students are having trouble getting an Azure machine. They email Microsoft and don't get an answer, so some of them are using Google Cloud, which is fine. Although I still never got the free Google Cloud credits for you, so you might have to just wait for Azure. Okay, this happens to me. Hold on a minute. If I go to Modules, there we go. Now it'll let me go to Student View. Nope. All right. All right, I have more trouble with Canvas than usual. Let's try going into a specific module. All right. Like the module 3 we want. I get the lecture here. I don't suppose I need to be in Student View to see that. All right, that's not bad. What if I let me in Student View yet? I sort of like to see what you people see now and then. All right, well, that looks about right. Okay, so you have to have some kind of cable or connector to connect your hard drive and your other peripherals to the motherboard on your computer. And one thing that used to be used a long time ago was SCSI, Small Computer System Interface. This was a big one. They're not that common anymore, but it's one cable and type of connector you can use to connect peripheral devices to your motherboard. Tape drives and hard drives and CD drives and all that. So if you have a computer that uses SCSI, you're going to have the SCSI cables, and you're going to have devices that can connect to SCSI. Yeah, I think iSCSI is just another version of the same thing. The next version, there's some extra features. I'm pretty weak on it. I've never used SCSI, in fact. IDE is what I used, because I came in for the cheap home version of computers, and a little bit later, IDE is the main one I used. It looked like this. Remember these connectors with the parallel pins and the gap in the middle? This is what most of the hard drives and things I had, these ribbon cables. In fact, in the days of IDE, you could do a forensic examination. If you wanted a write blocker, all you had to do was snip one of these wires. One of these wires was the write wire, and one was the read wire. So you could just have a cable with one of these wires cut, and that was your write blocker. Now your write blocker has to be about a $300 expensive gadget that contains a computer chip and simulates a bunch of stuff. It's far more complicated. Anyway, that was the joy of IDE, and it was also called Parallel ATA. And now SATA is what replaced IDE, and I think most of us actually have SATA if you have a desktop computer anymore, although most of us have switched to laptops. Yeah, iSCSI is used. Yeah, I've never used it hands-on. It's around. Anyway, so SATA, this is really common with these very few pins and a little notch in the end so you don't get it plugged in backwards. That's the most common one you'll find. And there's also something called external SATA too. That's another connector. So anyway, once you've connected with whatever connector is required to a hard disk, there are various ways to copy a hard disk. Now, what most people do is run a backup program that backs up their data from a hard drive, and that only copies the active data. So if you have a 1 terabyte hard drive, but you only have 100 gigabytes of data, your backup will only back up the 100 gigabytes of used data. It doesn't bother backing up the empty parts of the disk, because why would you? And that's fine for normal people who just want to save their files, but it's not good enough for forensic examination because you want to recover the deleted files, so you do want to copy the supposedly empty parts of the hard drive because they have remnant data on them. So in that case, the most common thing a forensic examiner does is create an image with something like FTK Imager, and that will read every bit on the drive, and it'll put it in a file, typically a compressed file. We have a single file which contains all that data. But you could also do a clone of the disk onto an exact same size disk. And there are hardware disk cloners you can buy, and some people like these, where you just plug in the 2 disks and you press the button and it copies from here to there. It makes an exact one-for-one copy. And this is something you might do if you want to deploy a whole fleet of desktop machines. You just clone the drive and then put those drives in the machines, and they'd all have identical copies of the operating system. And you can use it for forensic purposes too if you want. Have an exact duplicate copy of a hard drive, although that is not usually what you really want. You'd rather have an image file, so you take a machine with something installed on it like Autopsy and open the image file. You don't really want one hard drive that's an exact clone of the hard drive. You'd rather have a file that you can move around and feed into other programs. But anyway, both of them will serve the purpose of preserving the forensic evidence and making it available for examination. So as I mentioned before, I certainly hope I have, you never do a forensic examination on an original copy of a hard drive. You copy the hard drive, you take the original hard drive and lock it up in a safe with an evidence form recording the chain of custody, and you work on copies. And if it's a typical lawsuit or criminal case, you make 2 copies, you verify them with a hash value, you give one to the prosecution and one to the defense, and they both analyze those copies, and that's what they go to court with. And then in court you pull the thing out of the safe and say, wham, this is it, this is the hard drive from which all that evidence came. You have to have the original thing to take to court with the chain of custody form proving that nobody has meddled with it, but in fact all the examination comes from copies. Anyway, so you can clone a drive. Here's apparently a picture of a disk cloner. This one's not as obvious as most of the ones I've seen. Anyway, now it is a good practice to erase the drive you're going to put the data on first. You should forensically erase it. Some people like this so-called DoD-approved 7-pass erase. I don't think that's actually true, that DoD has approved this. This is a very common discussion. There's a common product called Derek's Boot and Nuke, where you boot a CD and it wipes out the drive. Some people have said you must have a multiple pass erase. Most tests I've seen say just 1 pass of zeros is enough to get all the data off a disk. But anyway, you should be able to say that I removed all the data off the drive I put the evidence on, so I know that all the files on that drive came from the evidence machine. I mentioned before there was a case that went to trial with an examiner that just used an ordinary laptop connected to the internet that he was using for other purposes for forensic examination, and then tried to present evidence that in fact came from his own system, not from the evidence drive. And you don't want that happening, so you want to be able to say, I put it on a clean drive that had nothing else, so everything on that drive came from the suspect machine, the machine I'm examining. That's just reasonable precautions. All right. So then now everybody is pretty much using solid-state drives. They're not really using these magnetic rotating drives on newer machines and laptops and iPhones. And they're all using solid-state drives, which are more expensive, but they're faster and use less power. And the thing about them is they do remember when the power goes off, but the way SSDs work, you can only write large blocks of data, so you have to create large empty blocks of data to store data. And they also have a limited number of read-write cycles before they wear out. So when they're always trying to reshuffle the data and clean it up to make these large blocks of available data to make the performance good. So they have a process in the background called garbage collection that deletes data that you're no longer using. So in general, you cannot recover deleted files very much from SSDs. There are sometimes little fragments of them that haven't yet been swept up by garbage collection, but it's not at all like a hard drive where you can really recover large amounts of deleted files. Anyway, and also, by the way, sometimes garbage collection is not running because you haven't got the right cables or the right drivers on both ends. So sometimes SSDs act just like hard drives and have a bunch of deleted data, but often they don't. So anyway, a lot of varieties of firmware and such. They're more efficient, which is why people use them. Smaller and they use less power, so you can put them in your iPhone. And that's the game. So they call this trim, and trim is an operating system function that tells the hard drive when a file has been deleted. See, a magnetic hard drive does not know when a file has been deleted. You delete a file, and it just makes a mark in the master file table, but the magnetic hard drive doesn't understand what the master file table is. It just sees a bunch of files, so when you change that mark, it does not know that that means these clusters are now available and can be erased. So it cannot preemptively erase them, and it doesn't. But if you have trim running, SSDs do understand when you delete a file. Now it's okay to do garbage collection over there. And that's more details of how it works. All right. So RAM is where you store data while you're using it and programs while you're running them, but it forgets as soon as you turn the power off. By the way, that is not instantaneous. There's a cold boot attack which showed this off. If you turn off the power in modern memory, it decays gradually over a period of a few seconds, and if you cool it, it will remember for up to half an hour, perhaps even longer. So that's interesting, but anyway, it doesn't remember overnight or any really large amount of time, so for all practical purposes, if the power's off, there's nothing in RAM. All right, so if you want to analyze RAM, you have to do a live collection. You have to capture this data while the machine is powered on, and that means you have to run a program on the suspect machine to image the RAM. So this is the modern technique, which is called live acquisition, and it is much less perfect than the old dead acquisition where you would pull the plug, turn off the power, and just image the storage drive. That was the old technique maybe 15 years ago that was standard. But now you want the RAM data. So you run forensic software like FTK Imager again, or you analyze the RAM, you collect a copy of the RAM while the machine is running, and that means some of the evidence on that machine comes from the forensic examiner. So, all right. Anyway, so RAID comes in. RAID is, of course, used by not very many home users, but many businesses these days. You're worried about one disk failing and your data getting lost. And so you get a whole bunch of disks working together with multiple copies of your data, often striped in pieces across these. So if one or two drives fail, you can recover from that. There's all different kinds, RAID 1 and RAID 10 and RAID 20 and RAID 5. Anyway, you have a big unit like this with a lot of drives. And the point is, if you're going to image that, you've got a big job to image this. And in large servers like this, the data is often shared by many users. So you frequently don't bother trying to recover deleted files. You just get the active data for the user that's appropriate to your case. But you could take all these drives out, image them all, and then try to reconstruct the data from the stripes across those drives. It would be a big job. It can be done, but it's not that common. FireWire and Thunderbolt are connectors that connect to external devices. And then, of course, you got these USB flash drives that have pretty much replaced floppies, just a way to temporarily store data. And these have data remnants in them. They usually do. I don't think I've ever heard of garbage collection on a flash drive, so I think you can recover deleted files from them. By the way, it's also impossible to completely erase them, as far as I can tell. I have some in my office from years ago that I got from the campus police, and I researched for years if there's a way to really completely erase them, and there doesn't seem to be. Are either FireWire or Thunderbolt still in use? Well, I think Macs are still using some versions of Thunderbolt. And I think FireWire is only on older machines. I don't think you can buy new FireWire anymore. Yes, you can destroy them with a hammer, but they wanted to clean them so you can just reuse them. And in principle, you cannot totally erase them. In practice, you can probably erase them. There's only a little bit left. And you can argue whether it's okay to have a little bit of data left on them or not and reuse them. Probably it's not a giant risk, but there is some risk. That's why, when you have corporate data, you typically want to be able to tell your corporate oversight board and your government compliance committees and stuff that we made sure that none of our data was leaving. So if you donate computers to a school or anything, you just physically destroy the hard drives. That's the only way you can really be sure that you didn't. And the same thing with flash drives. Physically destroying them is the way you can really testify, I made sure nobody else got that data. If you're running through some kind of erasure process, how can you ever really be sure you got all of it? All right, and then of course external hard drives. You connect remotely with a USB or some other connection and you have an external drive out here. It adds a lot of storage to your machine and you can analyze this. So this one common use of this is for Apple's Time Machine. You connect a remote drive every time you use it, and therefore it has live backups and you can roll back. So that's anyway, if you're going to do that, they say don't just pull out the USB. You might want to image it before you do that. All right, you can take it apart and image the drive if you're willing to power it down. One reason, by the way, why you might again stick to a live acquisition is a lot of people encrypt their drives these days with File Vault or BitLocker, so the whole drive is encrypted when the power is off, and you're not going to be able to analyze any data you find on it. So you might want to just image the whole thing while it's connected and running, if you can get it in that state, and logged in. Then you'll get all the live data off it, at least. You won't be able to recover the unused data, probably, but at least you'll get some of it, and it won't all be encrypted on you. Then there's these other cards, old multimedia cards, and now the SD cards that you see on cameras and a lot of other devices. They're just like thumb drives, go in and store a lot of data, and again, you can analyze these things. Anything with data on it, you can collect it. Compact flash cards, memory sticks for Sony, all work the same way, more and more of these cards. And then you got the optical drives, compact discs. I don't know if these are common anymore. CDs stored originally for music. Some people put software on them, and some of you users can write. Then DVDs and Blu-rays. I guess Blu-rays are still around. Anyway, most of these Blu-rays are commercial ones that contain movies, and that's of course not interesting because the movie is not evidence of whatever this person be doing with their computer, but all these come in writable versions where people store computer data, and that might have data that's relevant. And they all were optical. They store the data with a dye inside here, which can be changed by a laser. So they're changing the color of a spot of stuff, and they image it with a laser, so little colored dots are imaging the data. They read and write slower than magnetic drives, but they can store a lot of data, and they do remember forever without power. And of course, the old floppy disks, these are almost extinct, I think. And zip disks and other essentially extinct technology, all pretty much replaced by USB and CD and DVD. And there are magnetic tapes. There's a whole lot of different versions of this. A lot of people still use magnetic tape primarily for backup, because if you just want to store many terabytes of data in the cheapest possible way, that is actually magnetic tape typically, and so you use it for your weekly backup at a corporation. But home users, I don't think, use it much anymore. And they're just like hard drives. They're just a serial record of all the data. I don't even know if you can erase a file off a magnetic tape. You usually write the whole thing. Anyway, you can certainly collect the data off it just like a hard drive. All right, I think that's it for this one. Yeah, that's right. All right, so let's try a Kahoot. All right. Had this set up, but I accidentally closed that window. Mod 3, there we are. Okay. A little bit slow, but it's moving. Okay. I'll give it a few more seconds. Yeah, I see the A+. This is pretty much A+ data information today. Cables and hard drives and such. All right. All right. So what's the most common connector for hard drives? It's SATA these days. All right. All right. So what process makes a file containing all the data on an evidence drive? Yeah, you make a forensic image. You could clone it, but that's not the most common way to do it. And that doesn't create a file. That creates a hard drive image, duplicating the entire hard drive. It doesn't create one file with all the data. That's what an image does, and that's usually the most convenient way to do a forensic examination. All right, so what storage device might erase the old data automatically? Yep, that's an SSD. All right. All right, which one is read with a laser? That's a DVD. Hard drives are read and written with magnets, and these other two are just read and written with electric signals, but DVDs are optical. All right. A+. Well, I won't get their points unless they tell me who they are. Glow, I think we know who that is. One last will also have to tell me who they are if they want their points. All right. Aha, I see Glow's put a name up there. Good, I think we knew that anyway, but I'll make a record. All right, I'm going to stop the recording.